So we want the inverse of p, so why don't we begin by calling this y equals x squared minus 6x minus 3, and then we will actually do the swapping of variables so that this is x equals y squared minus 6y minus 3. Let me switch colors just in case you guys can't see that. I'll just use orange, I suppose. Now, we want to get y alone, so let's add this constant to the other side. So that'd be x plus 3 equals y squared minus 6y. Now, the reason we do that is so that we can complete the square. We want the y's alone. So now we're going to add a very special number to both sides. And that number is, well, let's see. You want to take half of this object, and whatever that is, square that. So half of that is -3, but -3 squared is 9. And that would be x plus 12 equals, and then recall the technique that we saw in class. This here can be factorized very quickly as follows. It's always going to be square, which is why they call it complete the square. You keep the first operation. We're using y's, and then you square root this or take half of that, same thing. And that was the point of completing the square, so that instead of writing y twice, you wrote it down only once, because you're trying to get it alone. You can square root this material, like that. And so this would just be y minus 3, and the square root knocks out the square, and that's plus or minus the square root of x plus 12. And then you guys can add the 3 to the other side. So that would be, and you can call this, instead of y, you should call it, we know we're gonna have to call it p inverse. So final answer, p inverse of x equals, we have plus or minus the square root of x plus 12 plus 3, because you add the 3 to the other side. There we are, final result.